So today we're focused on section 12.3, and this lesson covers factoring polynomials. So your skill practice work that you started on Friday is specifically aligned to factoring polynomials. So if that worksheet made sense, then this should just be a review. So your learning target says, I can use multiplication tables and greatest common factor to be able to factor polynomials. The first thing we're going to do is take a look at this visually with our algebra tiles. So example number 1 is going to be to factor using an area model. So essentially, if I'm given the equation x squared plus 7x plus 6, I know that visually with my algebra tiles, I'm going to have one large square, which is the x squared, 7 rectangles, which are my x's, and 6 small square units, which are my 1's. And I'm going to use all those pieces to try to build a rectangle. So I'm going to start with my large square. I only have one. I know I have 6 small units. And looking at my middle term, 6 units by 1 unit is going to give me what I need to fill in those X tiles and have a complete rectangle image. And then thinking about what we know with regards to area, the side lengths of my rectangle are going to be my factored forms. So I have an X plus 1 and an X plus 6, and I can check to see whether or not I did this correctly by multiplying through using FOIL. So my first terms, outer terms, inner terms, last term, and that polynomial should match my original in the example. For example number 2, we're going to use a multiplication table, and we're looking at the example x squared plus 10x plus 16. So drawing my multiplication grid, essentially I know x times x equals x squared. And I know that my constant is 16, so I need the factors of 16. 1 and 16, 2 and 8, 4 and 4, and I need to choose the pair that will sum to 10. So I'm going to choose 2 and 8, plug them in to the outside of my multiplication table. And then again, the sides of my multiplication table, x plus 2 and x plus 8, are going to be my factored form. And again, using FOIL, I can go through and confirm that I did that correctly. Moving on to Chapter 12, Section 4, we're going to look at solving quadratics by factoring. Again, this is all from your classwork on Friday. So your learning target says, I can solve quadratic equations to be able to connect zeros of a function. The x-intercepts of a graph, and determine the roots. So the first example we're going to look at just says x squared minus 4x plus 3. And I know that 3 only has factors of 3 in itself, or 1 and 3. So automatically I'm going to say x plus 3 times, or x minus 3 times x minus 1, because that 4 is a negative 4. Now I'm going to set each side of my factored equation to 0. So x minus 3 equals 0 and x minus 1 equals 0. And I'm going to solve for my x. So essentially I use my identity properties to subtract or add terms so that I get x is equal to 3 and x is equal to 1. I can plug those two values back into my original quadratic equation and confirm that when I do, my solution is true. I'm going to do a second example, x squared plus 10x minus 75. When I think about the factors of 75, I've got 1 and 75, 3 and 25, 5 and 15. 5 and 15 are the ones that are going to give me a sum of 10. So I'm going to use a positive 15 and negative 5. Set those two factored forms equal to 0. Solve for x. And then check within my original quadratic that those values give me a true solution. So I'm plugging in negative 15, and now I'm going to plug in that positive 5. Don't forget to always confirm your answers. This unit in particular is very simple to do so, and it makes total sense to check your work so that you get everything correct.